Understanding the National Electrical Code, or NEC, is crucial when designing electrical systems, even in confined spaces like a truck sleeper cab. The question revolves around wiring a 120 volts AC system with a 20 amp circuit breaker and multiple receptacles, some rated at 20 amps and others at 15 amps. The core concern is whether wiring the 15 amps receptacles with 14/3 wire off a 20 amp circuit breaker constitutes a tap, and if so, whether it complies with NEC regulations. According to the NEC, specifically section 210.19 A33 concerning taps, certain restrictions apply. Taps are not permitted on circuits protected by overcurrent protective devices rated higher than 20 amps. This means that the approach needs careful consideration to ensure safety and compliance. NEC section 210.19 elaborates further. It specifies that branch circuits rated at no more than 20 amps supplying one or more receptacles or outlets must have an overcurrent protective device also rated at no more than 20 amps. This reinforces the point that the circuit breaker's rating must align with the circuit's intended capacity. The initial setup involves a 20 amp circuit breaker, a 20 amps receptacle wired with 12/3 wire, and two 15 amps receptacles. While 12/3 wire is rated for 20 amps, 14/3 wire is rated for only 15 amps. This difference is crucial because using 14/3 wire on a 20 amp circuit could create a potential overload situation if the connected devices draw more than 15 amps. The situation with the 15 amps receptacles presents a challenge, especially since they cannot be replaced with 15/20 amps rated receptacles. If the 15 amps receptacles must be used, one solution is to protect the entire circuit with a 15 amps breaker. This ensures that the 14/3 wire and the 15 amps receptacles are adequately protected from overcurrent. However, this also means that the 20 amps receptacle will be limited to 15 amps capacity, potentially restricting its use. There is a better alternative, which involves using 15/20 amps receptacles and wiring the entire circuit with 12/2 wire. This approach allows for the full utilization of the 20 amp circuit, enabling the connection of various appliances and tools to any receptacle without the risk of overloading the 15 amps receptacles. Here is a breakdown of the key considerations. Firstly, overcurrent protection is paramount. The circuit breaker's rating must match the lowest rated component in the circuit to prevent overloads and potential hazards. Secondly, wire gauge selection is crucial. Using the correct wire gauge ensures that the wiring can safely handle the intended current. Thirdly, receptacle ratings must be considered. Using receptacles with appropriate ratings ensures compatibility with the circuit's capacity and prevents misuse. Here are some additional points to consider for your 120 volts AC wiring system. Firstly, always consult the latest edition of the NEC for the most up-to-date requirements. The electrical codes are subject to change, so staying current is essential. Secondly, ensure that all wiring and connections are performed by qualified personnel. Electrical work can be dangerous, and proper training and experience are necessary to ensure safety. Thirdly, use high-quality components that are listed and labeled by recognized testing laboratories. This ensures that the components meet safety standards and are suitable for their intended use. Now, let's dive deeper into some of the technical aspects to provide a more comprehensive understanding. Firstly, understanding branch circuit types is essential. Branch circuits are classified according to their maximum overcurrent protection. Common types include 15 amps, 20 amps, 30 amps, and 50 amp circuits. The type of circuit determines the types of loads that can be connected. Secondly, calculating circuit loads is crucial. The total load on a branch circuit should not exceed 80% of the circuit's rating. This helps prevent overloading and ensures that the circuit operates safely. Thirdly, grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock hazards. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, reducing the risk of electric shock. Let's also discuss some common wiring methods. Firstly, non-metallic sheet cable, or NM cable, is commonly used for residential wiring. It consists of 2 or more insulated conductors enclosed in a non-metallic sheath. Secondly, electrical metallic tubing, or EMT, is a rigid metal conduit used for protecting electrical conductors. It provides excellent physical protection and is suitable for exposed locations. Thirdly, flexible metal conduit, or FMC, is a flexible metal conduit used for connecting electrical equipment. It allows for movement and vibration without damaging the wiring. To further elaborate, let's consider the specific requirements for receptacles. Firstly, receptacles must be properly grounded. Grounded receptacles provide a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock hazards. Secondly, receptacles must be rated for the intended voltage and current. Using receptacles with the appropriate ratings ensures compatibility with the circuit's capacity and prevents misuse. Thirdly, ground fault circuit interrupters, or GFCIs, are required in certain locations, such as bathrooms, kitchens, and outdoor areas. GFCIs protect against electrical shock by detecting ground faults and interrupting the circuit. Now, let's discuss some common wiring errors to avoid. Firstly, using undersized wire is a common mistake. Undersized wire can overheat and cause a fire. Always use the correct wire gauge for the intended current. Secondly, over-tightening connections can damage the wire or terminal. Tighten connections to the specified torque to ensure a secure and reliable connection. Thirdly, failing to properly ground equipment is a serious safety hazard. Ground all equipment according to the NEC requirements to prevent electrical shock. Now let's examine the NEC requirements in more detail. Firstly, NEC Section 210.21 addresses the use of receptacles on branch circuits. It specifies the types of receptacles that are permitted on different types of circuits. Secondly, NEC Section 210.23 covers the permissible loads on branch circuits. It specifies the maximum load that can be connected to a branch circuit. Thirdly, NEC Section 250 addresses grounding and bonding requirements. It specifies the methods for grounding and bonding electrical systems to ensure safety. Also, let's discuss some advanced wiring techniques. Firstly, using wire connectors to make splices and terminations. Wire connectors provide a secure and reliable connection. Secondly, using cable clamps to secure cables to boxes and enclosures. Cable clamps prevent strain on the wiring connections. Thirdly, using conduit fittings to connect conduit to boxes and enclosures. Conduit fittings provide a secure and watertight connection. And now, some safety precautions to keep in mind. Firstly, always disconnect power before working on electrical circuits. This prevents electrical shock hazards. Secondly, use insulated tools when working on electrical circuits. Insulated tools provide protection against electrical shock. Thirdly, wear safety glasses to protect your eyes from debris. Now let's consider some specific scenarios. Firstly, if you are installing a new circuit, you must obtain the necessary permits and inspections. This ensures that the work is performed according to code and is safe. Secondly, if you are modifying an existing circuit, you must ensure that the existing wiring is adequate for the new load. This prevents overloading and ensures that the circuit operates safely. Thirdly, if you are unsure about any aspect of electrical wiring, consult a qualified electrician. Electrical work can be dangerous, and it is always best to seek professional help when needed. Here are several important concepts to reinforce your understanding. Firstly, ampacity refers to the current carrying capacity of a conductor. It is the maximum amount of current that a conductor can safely carry without overheating. Secondly, voltage drop is the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction. Thirdly, short circuit is an abnormal condition where current flows through an unintended path. Short circuits can cause fires and electrical shock hazards. To elaborate on the selection of appropriate wiring devices, firstly consider using tamper-resistant receptacles, especially in areas where children are present. These receptacles have internal shutters that prevent foreign objects from being inserted. Secondly, consider using arc fault circuit interrupters, or RFCs, to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. Thirdly, consider using surge protective devices, or SPDs, to protect against voltage surges. Voltage surges can damage sensitive electronic equipment. Furthermore, let's address energy efficiency in electrical systems. Firstly, use energy-efficient lighting fixtures and lamps. This reduces energy consumption and saves money. Secondly, use occupancy sensors to control lighting in infrequently used areas. This ensures that lights are turned off when they are not needed. Thirdly, use timers to control outdoor lighting. This ensures that lights are turned off during daylight hours. In detail, let's address troubleshooting electrical problems. Firstly, use a multimeter to measure voltage, current, and resistance. This helps diagnose electrical problems. Secondly, check for loose connections. Loose connections can cause electrical problems. Thirdly, look for signs of overheating, such as discolored wires or melted insulation. Overheating can indicate an overloaded circuit or a faulty component. Lastly, let's consider the importance of proper documentation. Firstly, keep a record of all electrical work performed, including wiring diagrams and component specifications. This helps with future maintenance and troubleshooting. Secondly, label all circuits and components clearly. This makes it easier to identify and work on the electrical system. Thirdly, store electrical documentation in a safe and accessible location. This ensures that it is available when needed. Remember that understanding and adhering to the NEC guidelines is not just about compliance, it's about ensuring safety and preventing potential hazards. When in doubt, consult a qualified electrician to ensure that your electrical system is safe and code compliant. Also, understanding grounding electrode systems is essential. This includes grounding rods, ground rings, and metal water pipes. A properly installed grounding electrode system provides a low impedance path for fault current to return to the source. In summary, designing a 120 volts AC wiring system for a truck sleeper cab requires careful consideration of NEC guidelines, wire gauge selection, receptacle ratings, and overcurrent protection. By following these guidelines and best practices, you can create a safe and reliable electrical system. The best approach is to use 15/20 amps receptacles and 12/2 wire. Ensure a versatile and safe electrical setup. By carefully evaluating the specific needs and constraints of the system, it's possible to create a safe, functional, and code-compliant electrical installation. Always prioritize safety and consult with qualified professionals when needed. Remember to prioritize safety, follow the code, and consult with qualified professionals when needed. Ensure all wiring and connections are performed by qualified personnel using high-quality components. Stay current with the latest edition of the NEC for the most up-to-date requirements. By following these guidelines and best practices, you can create a safe and reliable electrical system.